Okay, this is 4.2 homework. First problem wants us to give these 6 different trig function values, which we want to familiarize ourselves with. So the first would be sine of x, which we look at the angle and say, okay, sine is opposite over hypotenuse. So that'd be 40 over 41. We can just enter that in like that. And if you do the Pythagorean theorem on this triangle, you're going to get 9 for this side, which is important because when we go to do cosine, we need adjacent over hypotenuse, which is 9 over 41. Tangents opposite over adjacent, so that's 40 over 9. Okay, cotangent's the reciprocal of tangents, that's 9 over 40. Secant is the reciprocal of cosine, so that's 41 over 9. And cosecant is the reciprocal of sine, which is 41 over 40. And if you want an easy way to remember this, at least I think it's easy, you have sine, cosine, and tangent, which are our normal ones that we studied in geometry, our 3 basic trig functions. Now, the inverse of sine is cosecant, inverse of cosine is secant, and the inverse of tangent is cotangent. And the way that you can remember that is, obviously tangent and cotangent go together, that's pretty easy. But cosine and cosecant, they both have a co in the pairs. So you'll notice there's a co there, and there's a co there. So each pair should have one co in it, basically, as an easier to remember. That way you can't screw this up, because if you go with sine and secant as being inverses of one another, there's no co, right? So I think that's a pretty easy way to keep it straight. Next problem's pretty easy, 165. If you want a coterminal angle, 165 is somewhere, I don't know, over here. You just add 360. So if you add 360 once, you get 525, and you just go around back to the same spot. You add 360 again, you get 885, and if you add it again, you get 1245. Those are all coterminal angles. You could subtract 360 as well and go the other way. That would work too. Okay, the next problem is a little trickier because we need to find an angle between 0 and 360. That's coterminal with the given angle. So you got to figure first where the given angle is, and then figure out how many times you need to add or subtract 2 pi in order to get in this range. So the first angle is 13 pi over 5. Now that's, if you want to do this as a decimal, for example, it's really 2.6 pi. So that helps because you can look at it as 2 pi plus 0.6 pi. And you can say, okay, well that means I go around 2 pi, and then I go around another 0.6, which 0.6 is obviously a little over half of pi. So it takes me to right here. I go all the way around and back to here. That's important because then I can see, okay, I can subtract 2 pi to get back to this same spot. So that's what we want to do. We want to take the original 2.6 pi, or I'll just do it as a fraction, 13 pi over 5, and we want to subtract 2 pi. So we need a common denominator, multiply the top and bottom by 5, and then subtract and you get 3 pi over 5, and that's what we want. I'm going to enter in 3 pi divided by 5. You just keep repeating that same process. So negative 7 pi over 3, you got to figure out where that is. So as a decimal, it's negative 2.3 repeating pi. So that means we go, you can look at it as, like I said, negative 2 pi plus negative, 1/3 pi. And that way you can see you go back the other direction, 2 pi, and then you go back another 1/3 of pi. So it takes you to like here, which, you go all the way like that. Well, we want to add 2 pi. If we add 2 pi to that, that would take us from here all the way back to here, but we need to go once more around because we need this to be a positive angle. So we actually need to add 4 pi this time. So let me get rid of this, and we're going to take the negative 7 pi over 3, and we're going to add 4 pi, and then get a common denominator, so this would be 12 over 3, add and you get 5 pi over 3. So 5 pi over 3 takes us right to that same spot, but this time we rotate positive, so we're between 0 and 360. So I'll put 5 pi over 3 there, and use pi for pi. Alright, the next one, 73 pi over 2 is really 36.5 pi. So that means we rotate around, 36 times, or actually 18 times, and then we have another half of pi, which would be, here. So we know our angle is right here. Well, we need to subtract from that 36 pi, because that will just leave us with the half pi. That will take us to there. So subtract 36 and we get pi over 2. Or 0.5 pi. And the last one is 15 pi over 9, so you can look at where that's at. That's like 1.6 repeating pi. So that means we go around 1 pi and then 0.6, so it's somewhere around here. And that is between 0 and 2 pi, so that's a problem for us because we can't add 2 pi, so we can't stay within this range by adding or subtracting 2 pi, so that's got to be our answer, 15 pi over 9. We can't find a coterminal angle, or a different angle anyway, that's between 0 and 2 pi, because that's the one that's between 0 and 2 pi. Okay, for the next problem, it says suppose we have a right triangle with legs A, B, and C, hypotenuse C, and they give us 2 of the values, so let's go ahead and draw that triangle like this. Now they tell us that B is 3, they tell us that C is 5. If we do the Pythagorean theorem, we get A is 4, and then we can find the sine of A. The sine of angle A, remember, is across from side A. Angle B is across from side B, and angle C is across from side C. So to find the sine of angle A, we would do opposite over hypotenuse, which would be 4 over 5. Cosine of A would be adjacent over hypotenuse, which would be 3 over 5. And tangent of A would be opposite over adjacent, which would be 4 over 3. The next problem gives us a right triangle. If we do the Pythagorean theorem, we get the hypotenuse here is the square root of 34. We're going to need that. We can then do the sine of x, which is opposite over hypotenuse. And then the cosine is adjacent over hypotenuse. So that'd be of what? Well, I'll do the x's first. Tangent of x is opposite over adjacent, 3 over 5. Secant is the reciprocal of cosine. So let's find the cosine of x would be 5 over 3. So the reciprocal of that would be 3 over 5. I'm sorry, cosine would be 5 over square root of 34. So we want the reciprocal of that, which is square root of 34 over 5. And then cosine of y, adjacent over hypotenuse, that's 3 over the square root of 34. And the cotangent of y is, tangent would be 5 over 3, so cotangent would be 3 over 5. And cosecant is reciprocal of sine of y. So sine would be opposite, so it would be 5 over square root of 34. We want the reciprocals, we want square root of 34 over 5. Okay, just to remind you of your special right triangle values, they tell you that find the value of B and C. So we want this value, we want the leg and the hypotenuse. If this angle is pi over 4. Well, if this angle is pi over 4, so is this one. Pi over 4 is 45 degrees. So we have a isosceles right triangle. And we know that if this is B, so is this, or if this is 3, so is this. Right there, they're the same. And then we learned that whatever these are, if this is B, we can call this B square root of 2. It's always the square root of 2 times the leg. That's our special right triangle value. So this is just 3 square root of 2. So B and C, B is 3, and C is 3 square root of 2. Next problem gives us a triangle, tells us x is 5, y is 12, and z is 13. So the cosine of theta, here's theta, a little hard to see. It's adjacent over hypotenuse, that's 5 over 13. Sine of theta is 12 over 13. Tangent of theta is opposite over adjacent. Cosine of phi is then adjacent over hypotenuse, that's 12 over 13. Sine of phi is opposite over hypotenuse, that's 5 over 13. And tangent of phi is opposite over adjacent, 5 over 12. Okay, the next problem, I'll skip a lot of this. You can read this if you want. It says that basically we want a line drawn from the origin forming an angle of 7 pi over 6 with the x-axis, and intersects the circle at this point right here. So if you draw that picture, it should look like this. That's one of our special right triangle values, and the special right triangle, you can see this is 210 degrees, or on our unit circle, because you go 180 plus 30 more, plus pi over 6 more. But if you don't know that, you can just convert it, the same way we always do, where you multiply by 180 over pi, so that you get it in degrees. Pi's cancel, 6 goes 180 30 times, 70 is 210. So either way, you get 210 degrees right there. Now the next question is, what's the cosine of t? Well, the cosine of t is going to be, on our unit circle of the x values, it's going to be negative square root of 3 over 2. There's actually different ways to look at this. You could actually make a triangle here too and say, well, this is negative square root of 3 over 2. This is negative 1/2 here. And this would be 1 if you do the Pythagorean theorem. Hence the unit circle. Now you can do cosine, which would be adjacent over hypotenuse to get that square root of 3 over 2. So you can always make a reference triangle to get this as well, if you don't remember that cosine is the x value on the unit circle. But the sine of t is the y value of the unit circle, so that's negative 1/2. And then tangent is opposite over adjacent, or y over x. So it's going to be negative 1/2 divided by negative square root of 3 over 2. So double negatives are going to cancel. It's going to become 1/2 times 2 divided by the square root of 3 if you multiply by the reciprocal instead. In which case the 2's cancel and you get 1 over the square root of 3. Now it might accept that, 1 over the square root of 3, so you can try that, or you can rationalize the denominator by multiplying the top and the bottom by the square root of 3, in which case you get the square root of 3 over 3, which is the same exact numerical value as this, just represented differently. And this is actually considered simplified, probably because back in the day they didn't have calculators, so they had to memorize these values or look into the table for a value for square root, in which case it'd be easier to have that in the numerator and then divide by a number than it would be to take a number divided by that decimal. The next problem gives us some clues. It tells us we have an acute angle, so we're going to always draw a picture. That helps us immensely. An acute angle, we know we're in the first quadrant. The cotangent is equal to 1. That's actually important too because it tells us that cotangent's the reciprocal of tangent, so that'd be actually cosine over sine, because tangent's sine over cosine. So if we know that cosine over sine is 1, what that means is that has to be a 45-degree angle. Because what that's saying is that, you know, this on our unit circle is the point square root of 2 over 2, comma square root of 2 over 2. And, if we take cosine, which is the x value, square root of 2 over 2, divided by the sine, square root of 2 over 2, we're going to get 1 there. So that's a 45-degree angle. Another way to look at this is you can label these. This is square root of 2 over 2, this is square root of 2 over 2, so it's an isosceles triangle. It's a 45, 45, 90 triangle, where this is 1, right? Because it's this times the square root of 2, which ends up giving you 1. So from here, once we have our reference triangle drawn, it's really easy. Sine of theta is, opposite of our hypotenuse, or just the y value, square root of 2 over 2. Same with cosine. Tangents, opposite over adjacent, which ends up giving you 1, right? And then secant is the reciprocal of cosine, so it's 2 divided by the square root of 2. I'm not sure if they want you to rationalize that denominator or not. But cosecant is the reciprocal of sine, which is 2 over the square root of 2. The next problem wants the tangent, wants exact values here. Once again, we're always going to draw a circle, draw a picture, or look at our unit circle. We want negative 60, so that's here. And we know the values for that on our unit circle are 1/2, comma, negative square root of 3 over 2. So then we can, you can draw a reference triangle if you want, where you can label this 1/2 and label this negative square root of 3 over 2, and this will be 1 if you want, and then find these values. Tangent is opposite over adjacent, or y over x, sine over cosine. So it gives you this. Instead of dividing by a fraction, let's multiply by the reciprocal, in which case the 2's cancel and you get negative square root of 3. The cotangent is just the reciprocal of that, so it's really 1 over negative square root of 3 if you want. Just take it from there. Or you can do x over y. You're going to get the same thing. Negative 1 over the square root of 3. Next problem wants the cosine of pi over 3, which is 180 over 3, which is 60. So we want to go to 60, or divide pi into 3 equal parts, and we're going to go one third of that if you want to look at it. But we're here. We know on our unit circle this is 1/2, comma, square root of 3 over 2. And if it wants the cosine of that value, that's the x value, which is 1/2. And then same thing with negative 60 would be the same spot here, but it's the same x value. You still go out 1/2. You go down negative square root of 3 over 2 on the unit circle, but we just want the x value for cosine, so that's still 1/2. Next problem is just, once again, a reminder of your special right triangles, which are going to be really important for the unit circle. It's where all these values come from. We've got a 30, 60, 90 triangle, in which case we know that if this is x, whatever length this is twice that, and this leg would then be the small leg times the square root of 3. So when they give us the hypotenuse is 3.7, it's easy for us to divide by 2 and get this x value, which is 1.85. We'll call that the first leg. Second leg would then just be that 1.85 times the square root of 3 right here.